Well, hi, kids. Mr. Dorfler here for yet another video. We're back at doing it this way. Oh, we were so close. Got the taste of one day of having everybody or almost everybody back. I had a really good time on Tuesday when everyone was back. So it was awesome to see everybody back together. So hopefully in a couple weeks we'll be right back at it. But I am here today to present the Chapter 2 review. Now, again, if you saw my handful or so, or slightly less than handful, so post this morning on Classroom, the first post, completely ignore it. I ended up deleting it. But what I want to say is, if you did not read the post, I'm saying it in the video. I need you to come tomorrow, Friday, the 23rd, during your normal class time to take your Chapter 2 test. If you are a remote student and you have already reached out to me about a time, we're going to stick with that time unless things change with you. If you have not set up a time to come in and take it, please make sure you do that ASAP. And in my post, I made a mention that you need to arrive approximately 5 to 10 minutes before your normal class period would start, and I put those times in the post. So the reason for that is we need to make sure that your temperature is all good. So I'll need to do a temperature check, and I got something to mention on that here in just a second, and that might take a few minutes. All right. Now, if you're already in the building seeing another teacher before you come see me, your temperature's already been taken most likely, or it should have, so you don't have to get it taken again. But if you're coming into the building for the first time, you need to meet me down at the front doors near the main office. Before you enter the building, I'll take your temperature and I'll send you up onto my room as long as you're A-OK. Going back to what I said about temperature checks, it looks like we're trying to have somebody come in and be at the front door the entire day in order to take temperatures of students coming in. That'd be awesome, because that would save a lot of headaches from teachers running back and forth, especially those like myself who are a little far away and up a flight of stairs from the main office. So hopefully we'll have somebody down there throughout this whole time that'll just be that's their job, taking temperatures and saving everybody. I guess workout would be a good thing for me, but whatever. That's neither here nor there. Anyway, again, just make sure that you get a hold of me, like I said, if you're remote and if you have not set up a time yet. Otherwise, I'll see you all at your normal times tomorrow. That way I can give you any documents you need for the test, and you can also ask me any questions throughout the test. Also, that reminds me, make sure that you have your polyatomic ion sheet written up with your name on it, because you're going to hand it in to me when you turn in your test. That way all of your hard work does not go to somebody else who decided they didn't want to do the work. Regarding your polyatomic ions, yes, for your last quiz, I gave you that handout through Classroom that had a whole bunch of them, and towards the bottom of that document it said the most common ones. Yes, focus on those most common ones, but also the ones that are in your notes are the most important ones. I just said to cross-reference those, okay? I don't care how many polyatomic ions you have on there. That's up to you. How much work do you want to put into it? You can have all of your bases covered. I don't care, okay? But you have the option to do that. I'll give you your I'll give you your do not write on me periodic table, which I'll come around and make sure nothing's written on it. And I'll also give you your transition metal ion sheet, so you'll be covered. You could take, when the class period's over, as long as you don't have to go to some other class during their normal class periods, you can stay longer. I don't care. I'm not going anywhere, and that you're the only group of students that are going to be in class tomorrow. So that is fine. Make sure you have a calculator. All right. And what else? I don't think there's anything else. If I do, oh, yes. If you have not already turned in your last 3 or 4 questions for your problem set, okay, I know you were told last week to do them, but if you have not done them yet, make sure you bring them tomorrow to class, okay? Make sure you bring them tomorrow to class. Now I'm done. Now it's time to start the review, okay? So if you need to get your stuff ready for the review, get it ready, hit pause the video. We're gonna start here in just a second. If you wanna have a periodic table, which I highly recommend, you wanna have your notes ready, that's fine. Calculators, scrap piece of paper, anything you think that you would possibly need to help you with this review. But we're gonna start right now. There's about 12 or 13 or so questions on here, okay? So let's begin. Question 1. A molecule of water contains hydrogen and oxygen in a 1:8 ratio by mass. This is a statement of what? Now again, after I finish reading every question, if you want to hit the pause button so you can try to think about it, do it. But I'm not going to spend a whole lot of time waiting because you have the power and the magic of that pause button between question and answers to where you can take as much time as you need while you're watching this video. And I'm trying not to make it a super long video for you to enjoy today either. So moving on to the answer. That would be the law of constant composition. Yeah, water will always contain the same ratio of oxygen and hydrogen, okay? No matter where you get it from, okay? So that's why it's the law of constant composition. It will constantly be composed of that same ratio of hydrogen and oxygen. Question 2. What happens to alpha radiation when it is exposed to an electric field? This goes back to the early investigations by Rutherford when he discovered the types of radiation. Okay, those 3 types of radiation. So alpha radiation is positive. So when it is exposed to an electric field, it will be deflected towards the negative aspect of the electric field. Again, opposites attract. Positive alpha particles, negative field, they're going to attract each other. Question 3. What experiment led to the discovery of the atomic nucleus? This is a very important question or experiment that I said way back in the beginning of the chapter. I said, this needs to be highlighted, starred, whatever, because you're going to need to know it, and you need to know it now and for your test. Rutherford's gold foil experiment, where he had that very thin piece of gold foil where he shot alpha particles directly at it, and he had a screen that was surrounding almost the entire thing, and he noticed that most of the alpha particles just shot directly through. They were registered on the very backside, almost in a straight line from where the source of the radiation was. But then he noticed that there were quite a few of detections off to the sides at very sharp angles, some even almost going all the way back to the source of the radiation, which led to him to say, you know what, most of this is just empty space, but in the center there's got to be a very small yet highly dense core, if you will, of material really that's causing this to happen. Question 4. All atoms of a given element have the same what? That'd be the number of protons. Remember, you can change the number of neutrons, give us different isotopes. You can change the number of electrons to give us ions. But if you change the number of protons, you change the identity of the element, and you've therefore you've changed the element. Okay? So no changing the protons. Question 5. List the number of protons, neutrons, and electrons in copper 63. In copper, again, if you don't remember, this 63, this number up here, this is the atomic mass. This number down here in the bottom left, this is the atomic number. Okay, this represents the number of protons. And it also, in a neutral compound, or neutral element, I should say, the number of electrons. So we need to figure out all 3 of these. So if you need to pause, but we're going to move on. So there are 29 protons, as we see here with the atomic number 29. There are 29 electrons, as we see here, because there are 29 protons. It is a neutral element, so therefore they have the same number of electrons. Now to get the neutrons, remember you take the atomic mass divided by the atomic number to get the neutrons, and we have 34 neutrons. Moving on. List the elements that are diatomic. Think of David Hasselhoff's cousin. Okay, that would be Brinkelhoff. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Brinkelhoff. Easy to remember, right? Question 7. What does the molecular formula indicate? Remember, there's two types of formulas, molecular and empirical. But this is saying or asking, what does a molecular formula indicate? Molecular formulas indicate the exact number of each atom in a compound. An empirical formula gives us the lowest whole number ratio of elements in a compound, which essentially an ionic compound is an empirical formula. It's an empirical compound. Okay. Moleculars are typically ones where we see are covalent compounds are typically the ones that we see with molecular. Question 8. What is the formula of the sulfite ion? Again, pay careful attention to the endings, okay? But hopefully you're taking my advice, my brand new advice never done before, and you have this written down on your polyatomic ion sheet. SO3 2 minus. And again, sulfate, sulfite, nitrate, nitrite, phosphate, phosphite, perchlorate, chlorate, chlorus and hypochlorous, bromate, bromate. I can go on and on and on. But the endings all deal with the number of oxygens present in the polyatomic ion, or in those cases, since oxygen is present, we call them oxyanions. Okay, so just be careful about the number of oxygens and the endings present. Anyway, you will have the formula for sulfite is SO3 2 minus. Question 9. In the periodic table, the rows are called blank and the columns are called blank. The rows are called periods and the columns are called groups. Question 10. What is the name for Cr203? Now again, you always want to look for the metal on the periodic table and see where it is. If it's going to line up or be found in the transition metals, you can almost guarantee it's going to have more than one. Now, not 100% of the elements in the periodic or in the transition metals will have more than one ions that they can make, but the majority do. And you will have this chart given to you for the test tomorrow. And don't forget, if you have an element or if you have a metal that can form multiple ions, you must indicate which ion was used in this compound by way of Roman numerals. So, Cr203, again, if you do the reverse whoop and you take the subscript on the oxygen, put it back up as a charge on chromium, take the 2 on chromium and put it back up on the oxygen here, you will see that that gives us an indication as to what form of chromium was used. In fact, it was chromium 3 oxide. Again, it has a 3 plus charge when we put it back up onto chromium itself. So therefore, it is the charge is represented by Roman numerals of 3. And since it's only oxygen as the anion, it's only an element, so it gets the IDE ending. So chromium 3 oxide. Question 11. Give the chemical formula for magnesium sulfate. So here's what you want to do. Take a look at the periodic table and locate where the metal is. Okay? See what charge it is. Okay? We gave hints about where you can determine what the charge is going to be based off its location on the periodic table. Okay. There should be a video either on YouTube, on my channel, or way back when we started talking about this in the chapter, okay? It's somewhere. It's probably both locations, in fact. Anyway, write the charges out. Do the whooping, okay? Again, sulfate, SO4 2 minus. Magnesium is located in group 2, so it's a +2 charge. So when you whoop them, they're each going to have a 2 subscript placed on them. But remember, with ionic compounds, you cannot call it complete unless you have placed the subscripts into the lowest whole number ratios. So those subscripts of 2 that you placed on the magnesium and the sulfate, they essentially cancel each other out, and you get the formula of MgSO4. Also, I highly recommend you go over the rules when it comes to formula writing and naming starting with, I think, section 7 all the way through 8, with ionic compounds, covalent compounds, also called binary compounds, and acids, okay? It really all stems, a lot of it stems from, at least acid naming, stems from the rules of ionic compound naming. So go over those. One of the things I want to remember or remind you of is if you do place a subscript on a polyatomic ion and it stays there in your final answer, you have to put parentheses around the polyatomic ion and place that subscript outside of the parentheses, okay? Whew. Getting warm in here. Question 12. Give the chemical formula for disulfur dichloride. Again, so we're dealing with sulfur and chlorine, two nonmetals. So this is a covalent compound, so we have to use the binary naming. We're going to use those prefixes 1 through 10. Disulfur dichloride, so they both have the prefix of di. That means 2. So your formula is going to look like this: S2Cl2. Okay? This being a covalent compound, you don't do any whooping. You simply go off of the prefix of that is placed on the element. Okay? No whooping on covalent compounds. Question 13. So I guess there's going to be a little more than 12 or 13, but I think maybe 14 questions. Give the formula for phosphorus acid. Okay, so you see the OUS acid. That is an indicator as to what the ending was on the polyatomic ion. Okay, OUS is going to be representing the ITE ending of the polyatomic ion. So we're looking at phosphite. Okay, and since it's an acid, it's going to have hydrogen. Okay, and we treat this the same way we treat an ionic compound. Okay, hydrogen has a +1 charge, and whatever charge the polyatomic ion has, or element, if it's just a simple element, whatever that has, okay, go off that charge as well. Phosphite has a -3 charge. So when you whoop a +1 and a -3 together, you get the formula H3PO3. Again, you're going to have phosphite on your polyatomic ion sheet. Well, you should. I don't know what you're going to have on there because it's up to you on what you put on that polyatomic ion sheet. Okay, question 14. I believe this is the last one. Okay, looking at average atomic mass. So we have 3 isotopes of silicon in nature. Now, this is one that we've seen a couple of times now. We have Si-28, that is 92.23% with the atomic mass of 27.97693 AMU. Don't forget, AMU is the unit we got to use. Si-29, that is 4.68% with the mass of 28.97649 AMU. And Si-30, which has a percent abundance of 3.09% and an atomic mass of 29.97377 AMU. We are to calculate the atomic weight of silicon. So, again, if you want to pause this and try to set it up yourself, and we've seen this question before, but if you want to just try it yourself, go for it, hit the pause button. And what I'm going to do is I'm going to show you how to set this up, and then I'll show you the answer. Okay, save a little bit of time because I think the mathematical processes you'll be able to get pretty easily. It's the setup that I want to make sure you know how to do. All right, so since this is a setup problem, I'm going to go to my other camera, hiya, and if I can make some room here, I'm going to, first of all, I'm going to darken this up a little bit. So I have 3 isotopes, okay? One thing I need to do, I might as well move this over here, is before I do any calculating, I need to remember to take these percentages and take the percentages away. So I'm going to divide each of these percentages by 100 to make them into a decimal form, okay? Because all 3 of these percentages should add up to 100%. So what I'm going to do is I'm probably going to be bouncing back and forth here a little bit. So I've got Si-28, okay? It has a percentage of 92.23%. So again, we're doing average atomic mass. And so we have 92.23 for Si28. In decimal form, that's 0.9223. Okay. We then multiply it by its respective mass. Oh boy, I'm going to have to write these numbers down. 27.97693. Oh boy. Multiply by 27.97693. And I'm probably, because of how this is set up, okay, I'm going to rearrange this. When I mean rearrange, I'm just going to try to scoot it over so I can fit this all in. So again, average, we had 92.23%, so 0.9223 multiplied by its atomic mass of 27.97693 AMU. And then we add the next two isotopes. Okay, we had Si29 of 4.68. So that will be 0.0468 multiplied, sorry if you can't read my handwriting, but at least I'm saying it, multiplied by its percentage of 28.97649. So 28.97649 AMU. And I apologize, but I'm going to have to write the third one down at the bottom just because my whiteboard is not large enough. And my third percentage is 3.09%. So that becomes 0.0309 multiplied by its percentage, 29.97377. Okay, so 29.97377 AMU. So what you're going to do is you are going to multiply those two values together, multiply those two values together, and multiply those two values together. Once you've got those two values those three values multiplied together, you'll then take the products of those three and add them up. And so once you do that, you get your answer of, again, if you need to pause it right now, you better pause it now because I'm about to reveal the answer, 28.1 AMU. Now, if you look at all three of these percentages, Si28, Si29, Si30, Si28 has a percent abundance of 92.23. So we would expect that the average atomic mass for silicon would be closer to Si28 because it has a larger chunk of the pie. And so we see that 27.97693 is pretty close to 28.1. Okay, it's a lot closer to the average value than the other two masses of the other two isotopes. So our answer is justified. Okay, so there you have it. Oops. There you have it. If I can brighten me up a little bit. Ahaha. So again, at any time during this video, pause it. All right. I will be posting this review to Classroom in conjunction with this video, so you can have it to review. Again, when you come tomorrow to class, make sure you have everything that I listed early in the video. I only have a couple of calculators. I don't really want to lend them out. So if you can remember to pack one up after you watch this video, please do. Once you are finished with the test tomorrow, you can skedaddle out of the class, out of the building, or if you have to go to another classroom, you can go to another classroom. But until then, I will see you all tomorrow. Have a great rest of your day.